For the last 2 years, artificial intelligence has dominated every conversation in technology. It's in our headlines, our apps, our devices, and our investments. But while everyone's focused on AI, two other revolutions are quietly gaining momentum: quantum computing and edge technology. These aren't side stories. They're the next great leap forward, the engines that will power the digital world long after today's AI systems reach their limits. The future of computing isn't just smarter, it's faster, closer, and infinitely more powerful. Let's break down how the rise of quantum computing and edge technology is reshaping everything from energy grids to cybersecurity, and why the US is racing to lead this next phase of the tech revolution. Let's start with quantum computing, the holy grail of next-generation technology. If traditional computers think in bits, ones and zeros, quantum computers think in qubits, which can represent both 1 and 0 at the same time. This allows them to process information in parallel, solving problems that would take classical computers thousands of years to complete. The implications are enormous. Quantum computers could revolutionize drug discovery, financial modeling, climate simulation, and even encryption. They could find the perfect molecular structure for new medicine, optimize entire global logistics networks, or crack cryptographic systems that protect the world's most sensitive data. But here's the challenge: quantum computing is still in its infancy. Today's leading machines, built by companies like IBM, Google, and IonQ, operate with only a few hundred stable qubits. To reach commercial impact, experts believe we'll need millions of error-corrected qubits, and that may still be a decade away. So why is there so much hype right now? Because after decades of theory, quantum breakthroughs are finally becoming real. In the past 12 months, Google announced a new quantum processor capable of solving specific problems faster than any existing supercomputer, a milestone known as quantum advantage. IBM unveiled its quantum Heron system, which achieved record stability and scalability, and startups like Atom Computing and Rigetti are pioneering new designs that could make quantum computers smaller, cheaper, and more practical. Governments are also jumping in. The US has designated quantum as a national strategic priority, investing billions through the National Quantum Initiative to ensure America leads this frontier, not China. And it's not just about science, it's about security. Quantum computers could one day break today's encryption standards, making current cybersecurity systems obsolete. That's why the U.S. National Institute of Standards and Technology, NIST, is already developing post-quantum cryptography, encryption strong enough to withstand quantum attacks. In other words, the race for quantum isn't just about computing power, it's about who controls the next generation of digital defense. Now, while quantum represents the future of extreme performance, edge computing represents the future of extreme proximity. Think of edge computing as the opposite of the cloud. Instead of sending all your data to massive data centers for processing, edge technology brings computation closer to the source, to your phone, your car, your factory floor, even your traffic light. Why? Because not every task can afford the delay of sending information thousands of miles to the cloud and back. Imagine an autonomous car detecting a pedestrian. It can't wait half a second for a remote server to process that data. It needs to make a decision instantly, right there at the edge. That's the power of edge computing: speed, autonomy, and resilience, and it's growing fast. Analysts predict that by 2030, more than 70% of data will be processed outside centralized data centers, on local devices and edge nodes. This shift is transforming entire industries. In manufacturing, edge systems enable smart factories that monitor machines in real time and self-correct before breakdowns occur. In healthcare, wearable sensors and local AI devices are analyzing vital signs instantly, alerting doctors before emergencies happen. In energy, smart grids use edge nodes to balance loads and prevent blackouts. And in defense, Edge AI allows battlefield drones and vehicles to operate without constant connectivity, a game-changer for security operations. Here's the twist: edge and quantum are not separate revolutions, they're complementary. While quantum computing will handle massive complex calculations that require global-scale computation, edge computing will handle real-time, on-the-ground decisions. The AI systems of the future will likely rely on both quantum power in the cloud, edge intelligence in the field. Think of it like this: quantum computes the strategy, edge executes the move. That's why some of the biggest tech companies, from Microsoft to Amazon to IBM, are now developing hybrid architectures that connect quantum cloud computing with distributed edge networks. The vision is a world where data flows seamlessly between local intelligence and global computation, unlocking possibilities that today's cloud models simply can't reach. But as with every revolution, there are challenges. Edge systems introduce new security risks. The more devices that process data locally, the more attack points hackers can exploit. Quantum, meanwhile, faces immense engineering barriers. Maintaining quantum stability at scale requires near absolute zero temperatures and flawless control. Both technologies demand massive investment, and both could take years to mature fully. But together, they represent something far bigger than just technical progress. They represent a new phase in humanity's relationship with information. We're moving from centralized intelligence, where everything runs through a few giant clouds, to distributed intelligence, where computation happens everywhere, all the time. This is the architecture of the next decade: fast, local, intelligent, and interconnected. So what does this mean for businesses and innovators? It means opportunity, on a scale we haven't seen since the early days of the internet. Startups developing edge analytics, sensor AI, or localized cybersecurity solutions are exploding in value. Companies pioneering quantum algorithms are positioning themselves to dominate finance, logistics, and research in the 2030s.